Hello everyone, welcome to this lecture with a new topic, that is diagonalization of matrix. To start with, let us discuss the definition of diagonalization. The conversion of matrix into diagonal form is called diagonalization. So, in this process, the eigenvalue of matrix are represented by the diagonal matrix. And as we know that the diagonal matrix is a square matrix in which all the elements are zero except the principal diagonal element. So, diagonalization of matrix is defined as the process of reducing any matrix A into diagonal form D. So, uh, let us look at the process and solve example of diagonalization in this video. So, our process is, this is our process. So, in the diagonalization, the first step is find the eigenvalue. So, what is the eigenvalue? Eigenvalue is find with the help of characteristic equation, which is equals to a minus lambda is equal to 0. Now, second one, compute the corresponding eigenvector. Corresponding to eigenvalue, we have to find eigenvector. And now, with the help of these two steps, if we find eigenvector, now create the model matrix P. Model matrix P is nothing, it is a matrix in which all the eigenvector write in the column form. Now, step 4, find P inverse with the help of any method, whether it is a Cayley-Hamilton theorem or in the formula form, and in use the equation D is equal to P inverse AP, that is diagonalized form of D is the diagonalized form of A. So now let us see a example. So this is our example. First one is diagonalize the matrix A. A is a matrix which is 3 by 3 matrix. This is our matrix, and with the help of diagonalization, find the value of A raised to the power 4. Now start with, now the first two step, that is how to find out the eigenvalue and eigenvector, you have already been explained in the previous lecture of this video series. So refer that video. So in these examples, we will directly take the eigenvalue and eigenvector of this matrix. So, solution, the characteristic equation, as you know that, A minus lambda I equals to this is in the determinant form. If we, as I already told you, we directly use eigenvector and eigenvector value. So if we solve these equations, we get the lambda is equal to 1 minus 2 and 3. This is our eigenvalue. If now the eigenvector of this one, eigenvector is, eigenvector of corresponding to lambda is equal to 1. If we find lambda is equal to eigenvector corresponding to lambda is equal to 1, that is equals to minus 1, 4, 1. You will get this one. If you find corresponding to lambda is equal to minus 2, you get 1 minus 1 minus 1. If you get corresponding to lambda is equal to the 3, the eigenvector is 1 to 1. You already know how we find these values and these vectors. Now, so we start with step third. That is the construct model matrix. So model matrix is P is equals to x1, x2, x3. Write all the eigenvector in column form, we get model matrix. So our model matrix is first eigenvector is minus 1, 4, minus 1, 4, 1, minus 1, 4, 1, and second eigenvector x2 is equals to 1 minus 1 minus 1, and third one is 1 to 1, 1 to 1. Now if we jump in step 4, so our step 4 is find P inverse with the help of any method we use. Here we use formula method. So P inverse is equals to adjoint of P upon determinant of P. So first we find adjoint of P. Adjoint of P is equals to Cofact transpose of cofactor matrix. Cofactor matrix. So first we find cofactor matrix and then we find adjoint of P. So you already know how we find cofactors. So our cofactor is C11. C11 is equals to minus 1 raised to the power 1 plus 1. 1 is represented for row and this one is represented for column. If we eliminating first row and first column, first row and first column, what we get? This is a minor. So our minor is minus 1, 2, 1, and you already know okay, how we solve 2 by 2 determinants. If we solve this one, we get plus minus 1 plus 2, that is equals to 1. Now second cofactor is first row second column, minus 1 is minus 1 is raised to 1 plus 2. If we eliminating first row second column, we get 4, 1, 2, 1. Now if we solve this one, we get minus 2. Then if we get C first row and third column, first row and third column, minus 1 raised to the power 1 plus 3, we will be eliminating first row and third column, first row and third column, 4, 1, minus 1 and minus 2. 4, 1, minus 1 and minus 1. Now, if we solve this one, we get 4 minus 4 plus 1. So, plus of minus 4 plus 1, that is equals to minus 3. Now, similarly, if we follow this method, we get cofactor C21. that is equals to second row first column. If we solve eliminating second row first column, you get minus of 2. Now second row second column, you find minus 2, and second row third column, second row eliminating second row third column, second row third column, so minus minus plus 1, minus of 1, that is equals to 0. Now we get C3 1. Similarly, following this method, for finding cofactor, C31 is equals to 3. Now C32 you get 6, and C33 you get minus of 3. So adjoint of P is equals to P is P is equals to adjoint of P is equals to what? It is equals to transpose of cofactor matrix. So row right in the column form and column right in the row. So we get 1 minus 2 minus 3, that is row. So write in the column form. So here minus 2 and 0. Now last column is 3, 6 and minus 3. So adjoint of P is equals to, now we have to find determinant of P. So what is the determinant of P? You already know about how we find determinant of P, that is equals to minus 1 eliminating first row first column, minus 1 to 1, and second come with minus sign, minus eliminating first row second column, so 4 1 2 1, and third one is plus 1 if we solve first row third column, 4 1 minus 1 minus 1. Now if we solve this one, we get, if we solve this one, we get minus of 6. So our P inverse of P inverse is equals to adjoint of P, that is equals to 1 minus 2 minus 3 minus 2 minus 2 0, and 3 6 minus of 3. And what is determinant of P? Determinant of P is equals to minus of 6. That is right here. So P inverse is equals to minus 1 by 6 and adjoint of P. Now, uh, now we find diagonalization. So diagonalization is the equals to P inverse AP. Now we see that P inverse is 1 by 6, 1 minus 2 minus 3 minus 2 minus 2 0, 3 6 minus 3, and what is A? Value of A is go on the top, 1 3 2 minus 1 2 1, 4 minus 1 minus 1. So here we take 1 3 2 minus 1 2 1, and 4 minus 1 minus 1. And what is P? P is equals to minus 1 4 1, 1 minus 1 minus 1, 1 2 1. Now multiply all three matrices. What you get, you already know how we multiply matrix, one matrix with the another matrix. minus 1 by 6 is it is 1 minus 2 3 minus 2 minus 2 6 and minus 3 0 minus 3. Now if we multiply this matrix by this matrix, you already know how we multiply this one. First row with first column, first row with second column, first row with third column. If we multiply by this, 1 multiply by 1, that is equals to minus 1, minus 1 multiply by 4, that is equals to minus 4, and 4 multiply by 1, that is equals to plus 4. Now similarly, if we take this one, 1 plus 1, then minus of 4, that is equals to minus of 2. Now if we solve this one, first row third column, now 1 minus 2, then plus 4. So you already know this method, so we directly write an answer here. So we get, here we get, mm, here we get, if we solve this one, we get 4 2 6, 4 2 6, and here we get third row first column, third row second column, third row third column, we get 1 2 3. So directly we take a write an answer here. So our solution is minus 1 by 6, 1 minus 2 3, minus 2 minus 2 6, minus 3 0 minus 3. Now here our answer is uh, minus 1, minus 1, minus 2 3, 4 2 6, 1 2 3. Now if we solve this one, you get minus 1 by 6. This matrix multiply by this matrix. Similarly, you multiply this matrix, we get minus 6 0 0, then 0 12 0. Here we 0 0 and minus 0 and minus 18. Minus 1 by 6 multiply by this matrix, you get the diagonalized form. 1 0 0 6 6 1 is 6, 6 2 is 12. Here we get minus of 2 0. Now 0 0 3. You look here, student, this is a diagonal form in which all the principal diagonal are represented by a eigenvector, eigenvalue, and all the remaining elements are 0. So it is a D. Now student, with the help of diagonalizations, you find all the power of matrix, that is equals a square, whether it is aq, a4 and a raised to the power n, which is equals to an is equals to p d raised to the power n p inverse. So now we have to find a raised to the power 4. That is our second requirement. So if we find a raised to the power 4, first we find d raised to the power 4. A raised to the power 4 is equals to p d raised to the power 4 and p inverse. So what is the value of d raised to the power 4? D raised to the power 4 is equals to, if we multiply d 4 times, what we get? We get 1 raised to the power 4, 0, 0, 0 minus 2 raised to the power 4, that is equals to 16, 0, 0, 0, 3 raised to the power 4, that is equals to 81. Now, right here, putting these all three value, P. What is P? What is the value of P? P is equals to minus 1, 4, 1 and 1 minus 1 minus 1. and 1 to 1. What is the value of d raised to the power 4? D raised to the power 4 is 1, 0, 0, 0, 16, 0 and 0, 0, 81. What is P inverse? P inverse is equals to minus 1 by 6, minus 1 by 6 right here, and P inverse is equals to 1 minus 2 minus 3 minus 2 minus 2 0 minus 2 minus 2 0 3 6 minus 3. If we multiply this, what we get? First you multiply these two matrix and answer will be multiplied by this matrix. You get minus 1 by 6, minus 1 by 6. You already know how we find matrix multiplication. So here we write answer. Directly we write answer here. So minus 276 minus 30 minus 150, and if we multiply this one 450 here 24, then minus of 570, then minus 210, 30 and minus 336. Multiply minus 1 by 6, what we get? We get 46, 5, 25, then 75 minus 4, 95 and 35 minus 5 and 56. So that is our answer. This is all about our topic. For more details and examples, you can refer these books. Thank you watching this video. See you soon. Have a nice